Find the Fourier series of the function f defined by f of x equals to x minus pi is less than equal to x is less than 0 and x equals to 0 is less than equal to x is less than equal to pi. 0 minus pi x and y. Solution: in the problem L equals to pi, the function f defined by f of x equals to x, where minus pi is less than equal to x is less than 0 and x equals to x, 0 is less than equal to x is less than equal to pi, is neither even nor odd. Therefore, the trigonometric Fourier series of the function on minus pi is less than equal to x is less than equal to pi is given by 1 upon 2 a0 plus sigma n varies from n1 to infinity an cos n pi x upon L plus bn sin n pi x upon L. Equation 1. With L equals to pi, where the coefficients of an and bn are given by an equals to 1 upon L integral minus L to L f of x cos n pi x upon L dx, n equals to 0, 1, 2 and so on. Bn equals to 1 upon L integral minus L to L f of x sin n pi x upon L dx, n equals to 1, 2, 3 and so on. Thus, we have a0 equals to 1 upon pi integral minus pi to pi of f of x dx equals to in 1 upon pi integral of minus pi to 0 of pi dx plus integral 0 to pi of x dx equals to 1 upon pi into pi x limit minus pi to 0 plus x is integration is x square upon 2 limit 0 to pi equals to 1 upon pi into 0 and 0 plus pi, putting the value of the limit, plus pi square upon 2 equals to 1 upon pi square plus pi square upon 2 equals to 1 upon pi into 3 pi square upon 2 equals to 3 pi upon 2. An equals to 1 upon pi integral minus pi to pi of f of x cos nx dx equals to 1 upon pi into integral minus pi to 0 pi cos nx dx plus integral 0 to pi of x cos nx dx equals to 1 upon pi into integral 1 upon pi into pi sin nx upon n limit minus pi to 0 plus x sin nx upon n limit minus 0 to pi minus integral 0 to pi of sin nx upon n dx equals to 1 upon pi into 0 minus pi sin minus n pi plus pi into sin n pi upon n plus cos nx upon n square limit 0 to pi equals to 1 upon pi into 0 plus 0 plus cos n pi upon n square minus cos 0 upon n square equals to 1 upon pi into cos n pi minus 1 upon n square equals to minus 1 raised to power n minus 1 upon pi upon n square equals to 2 minus 2 upon n pi square, where n equals to odd, n equals to 1, 2 and 3 so on, equals to 0 when n is even. Now bn equals to 1 upon pi integral minus pi to pi f of x sin nx dx equals to 1 upon pi into integral of minus pi to 0 of pi sin nx dx plus integral 0 to pi of x sin nx dx equals to 1 upon pi into minus pi cos nx upon n limit minus pi to 0 plus minus x cos nx upon n limit 0 to pi minus integral of 0 to pi of minus cos nx upon n dx equals to 1 upon pi minus pi cos 0 upon pi plus pi cos n minus pi upon n plus minus pi cos n pi plus 0 upon n plus sin nx upon n square limit 0 to pi equals to 1 upon pi minus into minus pi upon pi plus sin n pi minus 0 equals to 1 upon pi minus pi upon pi equals to minus 1 upon n. So n equals to 1, 2 and so on. Thus the required series is 3 pi upon 4 plus sigma n varies from 1 to infinity into minus 1 raised to power n minus 1 upon pi n square into cos n pi x upon pi minus 1 upon sin n pi upon pi x upon pi, the sin n pi x upon the pi equals to 3 pi upon 4 plus sigma varies from n1 to infinity into minus 1 raised to power n minus 1 upon pi n square into cos nx minus 1 upon n sin nx equals to 3 pi upon 4 minus 2 upon pi cos x plus sin nx minus 1 upon sin 2x minus 2 upon 9 pi cos 3x plus 1 upon 3 sin 3x minus 1 upon 4 sin 4x so on.